Hello from Prota Software. My name is Çağlar, and today we'll be looking at modeling, analyzing, and designing of steel stairs with my colleague Volkan Öğüt, who is based in Poland. Before we start, I would like to talk about Prota just for a few minutes. Prota have been around since 1985. And it's not just a software company, but also a huge consultancy firm, having executed numerous projects in more than 20 countries. Prota consists of 6 companies under Prota Group, and they have been around quite some time now. We are also expanding in the world as well. Every year we are growing. We operate with more than 15 offices located in Malaysia, Singapore, Philippines, Poland, and Turkey. Besides our regional offices, we support our customers and provide services through our channel partners located in Europe, Africa, Middle East, South America, and Southeast Asia. Sorry. Okay, ProtaStructure. With ProtaStructure, you can model, analyze, and design multi-material building structure using a structural BIM model. Then this BIM model can be shared to different BIM platforms like Revit. And after you're done with your design, the reinforcement details can be automatically created using Prota Details. Then the design can be pushed to ProtaSteel for connection design and fabrication purposes. We also have links with OpenSeas and SAP and ETABS for data exchange. And you can then extract your design reports in Office and PDF files. Okay. Today we'll be focused on mostly ProtaSteel. I'll be doing a quick design analysis and design on ProtaStructure. Then Mr. Volkan will take over. As you know, ProtaSteel is the dedicated tool for automated modeling and design of steel connections and creation of steel drawings like general arrangement, part and assembly drawings. And you'll be also seeing interconnects in ProtaSteel. Today's webinar, I'll just start with modification of an existing structure. I'll be designing various types of steel members. Then when the design is ready, I'll just hand over to Mr. Volkan for further design of stairs. He'll also be showing the revolutionary interconnect for all automated connection design as he goes with the ProtaSteel. Okay. So if you're ready, we can just start. Let's see this in action. As you see, we have a model just like this one. We have a concrete structure, and we have three types of steels here. We have one staircase, rectangle staircase, a round stairs, and a roof here. Okay, so I'll just be doing some modifications on these models, and then I'll just push it for analysis, and then eventually with design. Okay. If we come here and focus on this structure here, first of all, as you see, we have modeled an existing structure here. What we have done here is that, let me go to plan view here so that you can see it better. Okay, what we did here is that this is, I'm not going into details on this one, how to design these. Like as you see, all these members are designed in traditional ways. What we did here with the stair beams is that we just played with its levels on the 3D function here, which you can do very easily. After we did the first floor, then this floor is generated to upper stories in order to create this structure. Okay. So what I'm going to do is I'm going to start doing some modifications on this. First of all, I'll go to modeling, and I'll just come to story number 1, and I'll start with girts. Okay, so let's just cover this staircase up. Okay, so with girts, as you see, we have a girt editor opening just like so. In this editor, you can come here and change the types, and depending on where you are, basically, you can select different sections here to suit your project, and you can also play with the geometries here. Spacings can be edited as you go. This screen on the right is all interactive, so you can see in real time what your changes are, and you can just play with the geometries as you go, as you like. Okay. You can also choose to delete the bottom and top members if you like. So this is very easy to use. Sag roads are you can do automated or manual. Sag roads can be inserted. Also, you can choose to have profile hanger or not, and other geometrical features can be edited here. You can also define loads on the girts. Basically, what you have to do is you can add a load here and input let's say 1.5. It has to be a minus value here, because in order to assign a load. Because if you put a positive value here, it will be from it will not be like a gravity. So it has to be a negative value here. So you need to pay attention to this one, not to get extreme analysis results. Then you can assign these loads as you like, just like so, and you can see the assigned loads just like this. Okay. So I'm not going to assign now because I'm going to add claddings as well on this one. You could assign loads and claddings at the same time. It doesn't matter. So what I'm going to do here is I'm going to continue on modeling my girts. Then I will just skip to cladding. This is the same. I'm just going to, if you're happy with the default results, you can again add loads or not. You can, if you're happy, you can just go ahead. Okay, and same can be done here, just like so. Okay. Let's have a look at cladding now. What you can do here is that, yeah, when you select the girts, then you can create your claddings on the girts, and we have some other geometrical features here which you can edit. Let's say 500 from left and top as well. As you see in the interactive screen, it's all being edited automatically. Okay. So the loads are the same. The same way you're adding the loads. That's just input minus. Minus 1.5 again, and then you can come here and select panels as you go as well. So you can assign these loads to particular palette panels depending on your project. On this one, I'm going to add it to at this point. I'm going to add it to all panels here, And as I hit OK, it will be defined just like this. Okay. So you can do the same in here. You can just add the loads, assign loads, and I'm just going to select all panels. Then it can be updated just like so. Okay. If you're happy with this one, you can just skip this one and go ahead like this. Now this is ready to be pushed to ProtaSteel for more further detailing, and we can skip this staircase and come here. I'm just going to quickly talk about how we did this one. Also, before I forgot, what we did here is that we defined these columns and as length stories here, as you can see, which means throughout the story, throughout three stories for manufacturing purposes. And the same one here, the tubular column is created with the same property here. What we did here is that we connected this tubular column with beams to this concrete structure with to shear wall and this concrete beam here, and you'll be seeing further detail in ProtaSteel on this structure. Okay, so if we come here and focus on this roof structure. As you see, this structure is modeled using plane definition here on these both sides. And what I'm going to do here is I'm going to show the truss editor. I'm gonna create trusses between these columns here, and as you go. The truss generator screen comes up, and you'll be able to see that we have different truss types here. You can choose different patterns from the pattern library, and then you can come here and edit the geometries of these selected trusses. For example, you could do a truss shape. It could be a curved one. And as you go, the interactive screen will update as well as you change these. Okay. Now I'm going to choose this V-shaped truss. If you're happy with the geometries, you could play it and you could just fit it to suit your project. Okay. And I'm going to choose top chord to be supported. And if you're happy with this, then you can actually push this model to user-defined trusses. Okay, we give a lot of flexibility on this recently introduced truss editor. You can create your own trusses by choosing by creating new points like this one, and maybe -500 as well. You can just create any type of truss with this recently introduced truss editor. I'm going to make some changes at this point. I'm going to delete these top chords and this vertical chord as well. And maybe we have a truss coming here. We have another member coming here, and I don't want to write them. And maybe we have another horizontal chord here. Okay. And I'm choosing vertical from here as I'm going to import a vertical element, and there we go. I just changed my truss in just a few seconds. You could also import trusses as well from the XF file. You have seen this feature in previous webinars. And if you're happy with this, then you can just hit OK, and just like so, it will be defined just like this one. Okay, so before I go to purlins, I would like to show you the frame element as well. Frame element gives you all the flexibility to model any kind of structure you want to, or you want to model, or make any modifications to a existing model. You can come here and select your section here, desired section from our large library. And maybe we have, in this case, a tubular section here. Could be this one. And if you're happy with this, just hit OK, and I can come here and make my frame element just like so. Okay. You could do this to anywhere. I can come here and just make another support here, just easily. Okay, and I could just move these, and I can make a support here as you go. Okay, so this is very easy to use, and it gives you all the flexibility you need modeling speed. Okay, so now I can put in my purlins here between these two trusses. Purlins can be created between beams and trusses, as you know. And the same editor comes on the screen again. You can manipulate these offsets as you go. As again, we have a interactive screen here. If you want to, for example, extend the cantilever length, you can from these inputs here. And if you're happy with this, you can just go ahead to sag loads, or all are the same, and loads as well are the same. And this time I'm going to add a load here. For example, I have maybe minus 1 kilonewton in each purlin. And you'll be able to see as you select the purlins, which purlin you're playing with. It will show you here, just like so. Okay. So that you know which purlins to define the load you want to define to. Okay. So what I'm going to do is I'm going to create these loads, assign these loads to all purlins on this project. And if you're happy with this, you can just go ahead with the purlin modeling, just like so. You could also come here and put a cladding on top. Okay. So it's very easy. You could add a load here as well. And if you're happy with this, you could just go ahead, just like so. Now our model is ready to be analyzed and all automated designs. And I can just quickly go to analysis section here. I would like to talk about project parameters a little bit. As you know, we support different codes all around the world for concrete, for steel design, and seismic codes. Or different seismic codes are supported by ProtaStructure. Okay. Loading combinations. We have steel members here. You can come here and select this box here to create different combinations for steel members. And you can come here and check the seismic loadings. I'm all happy with these, and hit OK, and we are just now ready for analysis. Okay. At this point, I'm just going to start the analysis very quickly here. Okay, you could do a all automated batch design for steel design, steel checks, but I'm going to go into a little bit detail in there, so I'm just skipping that. So our analysis is starting now. At this point, you could also analyze these concrete structures and steel structures separately, and then merge the analyzed models using the model merge editor in order to take it further into combined foundation design. This, as I said, all depends on the designing engineer and their approach. Both approaches are fine with ProtaStructure. So the analysis will take a few seconds. At the moment, all lateral and vertical loads are being calculated, and we'll just push it for design in a bit. We have now a much faster analysis engine. It's now supporting 64 bits, so it will just analyze complex buildings much faster than before. So our analysis has finished, and we have a summary here. I'm just skipping that, and we have our let's have a look at the analytical model quickly. I'm just going to go these ones, and yeah, you can see the analytical model here, just like so. As you said, frame members are defined just like so. The frame members I added before is defined here. I would like to show you some features here. If you focus on this building here, for example, all these red boxes are here are the intersection points. So you should know these how to evaluate the analytical model. And these purple marks are actually hinges, so that you can evaluate your structure after designing it, and you know where you define hinges or not. You can actually, you all know this analysis engine. You can come here and check the diagrams if you like moment diagrams, and if you increase the scale, you'll be able to see diagrams just like so. Okay. So I'm just skipping that to continue with the design part. I'm just going to quickly make a design for depending on the analysis results. I'll just go columns quickly, and you could also go and do a quick batch design for all the columns, all the steel columns in your model. Okay. So I just did a batch design, and design status looks good for all of them. And you can come here and evaluate every single column one by one. You can check the calculation details, and all the details can be checked here. All the checks are done, finishing checks. You can come here and evaluate. You could also come here and change section as well. For example, if we have put 200 HEA, and you can come here and change this section as well. And depending on that, these general parameters also changes depending on your change. So you don't have to go back and reanalyze the structure. Let's go with the default one. And as you see, all these checks are being updated as you change the section. Okay, so you can come here and have a look at diagrams. You can have a look at moment diagrams and shear force diagrams as you go under different load cases, and you could just create a design report for this particular column, just like so. Okay. So if you're okay with this, I'm going to quickly go to beams, and I'll make a quick batch design for all the beams in our structure as well. And as you say, it just takes a few seconds to complete the design, and all the beams look good. And you can come here into the same interface. You're familiar with these interfaces, and you can come here and change the section again if you like. And you can come here and have a look at diagrams. Maybe if you want to have a look at deflection diagrams, you can. You can just arrange the deflection display type here, and all the same diagrams. And then you can come here and create the design report for this particular beam. You can create design report for all beams as well. Then you can use the design report manager to collect them, and you can just go ahead. Okay. So what I'm going to do here is that I'm going to go ahead with purlins. Again, I'll just do a quick check, and you can come here, check these members one by one, and as you go with this design, as you see, and you can create the design for this one grid. Okay. So we did our design. So I don't want to spend more time on modeling and design. So this is so easy because it's all automated. Without spending more time, I would like to hand the presentation to Mr. Volkan to push this for further detailing in ProtaSteel for stairs detailing and other. He'll be using other macros to detail these steel structures. So thank you for listening, and I'm Mr. Volkan is taking off.
Okay, so I think I was muted, so I will repeat once more. So what I did, I selected ProtaSteel, and all these models were exported to the ProtaSteel environment. So now I will press to the F4 button, and I will press to the top view of 3D view, actually. So I will hide unnecessary elements via selecting and hiding these elements with this command. So now I will use our revolutionary feature, which is IntelliConnect. So IntelliConnect can automatically assess the joint and select the most appropriate connection according to the settings and the connection which is coming another direction. So let's select all model and start with the base plates. So in this case, I will select create base plate connections command here, and let's run the command. So we have generated the base plates. If you want, you can add anchors. So we can select the anchor macro here. I will right click, then select the plate. So as you see, so let me zoom in a little bit. As you see, the macro generated anchors for each hole of this plate. So let's continue with the column and beam connections. Again, I will use the IntelliConnect for this purpose. I would like to select extended end plate for the fixed connection. Also for the simple connection, I would like to use end plate connections. We don't have beam to wall connection in this U-shaped stair, so I can skip this. We can shift while we are connecting the beam column connections. We can shift the brace along the column like this, or along the beam. It's up to the user. You can set the shift increment and maximum shift value from here. So let's run this command. Even in seconds, more than 13 nodes will be connected, and normally such a time-consuming operation might take even days. So with manual macros or other stuff. So let's continue with the floor beams. Again, I will select all model, and I will run the floor beam connections macro here. Again, I will use the end plate connection. In this sample, we don't have lateral brace, so I will skip this option also. And the software is, as you see, the software is selecting the connections automatically here. Okay. So let's continue with the girts. Again, I will select all model and run the IntelliConnect with the girt connections. So we have several types, and we can also reverse them. It's up to the user. So in this case, I will select bracket type option, and let's run this command also. Okay. So even one-sided or two-sided brackets, all of them were generated in the software. So you can see there is no clash here. So it's been generated precisely, as you see. So what I will do here, as you see in the ProtaStructure model, these beams were generated by by piece by Mr. Çağlar. So I would like to see this beam as a single entity, I mean in a single assembly. So what I will do here, I will use, as you see, fitting connection macro here. So I will select both of this beam and the macro were created here. So let's talk about a little bit macro properties. So for each macro, we have plenty of properties about manipulating this macro. So normally you will see in the default version with the single plate like this. But what I did here, I have canceled the plate and use this option in the default with the get button here. We can also save this settings for further usage. You can create your own company's settings here. So let's continue to the creating the rest. So rest of them, I'm gonna click those beams. Okay. Okay, so if I select this beam and right click, then select the highlight assembly option, all these three pieces will seem in a single assembly. So it's important thing that we did here. So let's continue with the handrails. Okay, but before handrails, we can also add stair steps. So for this purpose, I'm gonna use the stringer holes macro. Okay, we can select those two beams and the stairs will be generated automatically. Again, with the M and Enter button on my keyboard, I can get into the macro properties, or you can select the macro icon, and you can also, with this icon, you can also show these properties here. What we can do, we can select the grating, checkered plates. Also, available plates might be selected from here. Let's apply the settings. The next thing that I want to talk about is handrails. So if you select the beam and double right click, handrails will be generated. So in this case, again, I would like to show you handrail macro settings. So again, M and Enter button to select the macro settings I have used. So as you see, we have some extension values for the handrail. For example, let's change like 250, but I will use the previous values. So you can also specify the distance between first vertical and the starting point of the beam. Also, you can specify the distances for intermediate verticals of the handrail. So all this can be done with the user. So with the knee plate settings, you can type in the starting distance or knee plate height from here. Let's say that we have 120 millimeters knee plate here. Okay, as you see, this change was applied instantly on the in the 3D view. Okay, let's continue with the other handrails. So again, I will select the handrail and double click. So if you have particular handrails, like in this part, you can select the beam, right click, then you can draw the handrail along the beam. Again, I will select my handrails here and double click. We have again particular handrail here. Okay. Let's continue to select handrails to generate handrails. I will do this just for one story. Okay. Maybe we have also a small handrail here. So what we can do, we can also draw a small handrail here, for example. Okay. Now what we can do, we can connect this handrail with the handrail connection macro. So I have selected handrail, first handrail, and then second handrail. After this, we can set elbow diameter from here. So in this case, I will use 30 millimeter here. So as you see, we can quickly select the handrails and it will be automatically connected. Normally, to create such a handrail may take a huge time in another softwares. So, but with the single clicks, you can do this in seconds. Okay. So the next thing that I want to talk about is floors. So for this purpose, we have floor modeler here. So what I will do here, I will select all these enclosed beam zone to create a floor here and right click. Again, let's do this. Doesn't matter, it can be also concrete members, so you can create this floor modeler. So with the Alt D button on your keyboard, you can select the wireframe view. And as you see, there are some stiffeners. You can see that I have selected. There are some stiffeners in the this floor modeler macro. So let's check out the macro settings. So what we can do, we can select the floor plate type here, checkered plate or grating. You can also change the stiffener type from here. It's up to the user. So we can click to the, after these changes, we can click to the, for example, checkered plate, apply and OK button. So lastly, I would like to show one of our macro which when we use connecting this kind of braces. So for example, I will use bolted gusset plate to connect this macro here. First, I will select the main brace, then splitted braces here and right click. Of course, this geometry of this plate might be set by the macro properties. So let's show all members. Let's show all members, and we have spiral stairs here. I mean, we will create spiral stairs. So in this case, again, I will hide actually unnecessary elements by passing to the top view. So let's hide these members in the view. Okay, maybe this also this slab might be hidden in the 3D view. So let's start with the first stories landing. So what I will do here, Mr. Çağlar created this beam from the center of the column. So what I will do here, I will create a cut object to until the surface of this column. So let's use for this purpose, let's use the cut this with that boundary command. Okay. First, I will select the beam, then column member, which will be cut object. So as you see, cuts were applied. With the Alt D button in the wireframe view, you can see that the cut is already applied to the member. So let's do this once more. Okay, from here. Again, I will select the cut this with that boundary option, select the beam, then column member, and cut were created. Again, with the Alt D button, you can see this. So what I will do here, I will add welds. Otherwise, it won't be seen as a single entity, I mean single assembly. So I will add welds here. What we can do, we can, with the create weld command, we can select the edge, then select the column. A weld will be generated here. Let's zoom in a little bit, then double right click here. We can play with the, for example, weld types, weld material here. But in this case, I will use default options. If you want, you can select the operational location. If you select site, so it won't be included in the assembly drawings. So let's select the weld type as all around and apply to the apply this. I will do the same for this part. Okay. Again, we can double click and make it all around of the beam. So in the visibility settings, I can you can see on the left side, we can close these cut objects here. So Mr. Çağlar also splitted these beams. So I will connect with them as splice connection. So let's select the splice connection and select these beams in the 3D view, and splice will be generated here. And the next thing might be, for example, these secondary beams connection. We can select the maybe end plate connection for this purpose. Select the main member, then secondary, and right click. Again, select the main and secondary, right click. So for this inclined beam, which has CHS section, we can use bolted gusset plate connection. So what I will do here, I will select the beam and this also this circular beam here and right click. Again, I will do the same. So you can play with the macro settings. So what I will do here, for example, I can change the height of this plate from here. If I click to the apply, it will be done in the also connection. Okay, can close this notepad. So let's reverse it and show this once more, this connection. Okay, so we can show this in this connection here. For example, let's do the same, like 50. You can see the change instantly here. Okay, so you can play with the macro properties. So in some cases, if it's not possible, it may not allow you. So in this case, it didn't allow me. But as you see, if it's possible, the software will allow you to do this change with the macro properties. Okay, the next thing that I want to talk about is corners connection. So what I will do here, I will select the connection which is here fitting connection macro here. Okay, so I will select those two beams, and you can see that cut object were applied and it's been welded also. Okay, we have several connections between concrete and steel members. For instance, you can use beam to wall connection macro and also embedded steel connection can be used for between steel and concrete members. So what I will use the beam to wall connection macro here. First, I need to select shear wall, then steel beam, and connection will be generated. For example, in this case, I have created a user-defined connection here. So I will select the user-defined connection here, and let's create this connection. The creation of user-defined connection is out of scope of this webinar. So you can check my previous webinar, which is user-defined connection webinar, actually. So we have talked about in a detailed way in this webinar. So please check this webinar for this purpose. So what I will do here, I will copy these connections to the upper stories. So first I selected members, then I will press to the M button to select the macro icons here, then right click and copy special. Of course, it may not copy some connections such as beam to wall connections and these inclined beams connections, but the rest will be copied to the upper story. For instance, let's see. The story height is 3 meters, so I typed in 3000 millimeter here. Let's copy. So as you see, these members were copied to the upper stories. If we do, as you see, the icons were already selected, so we can do this operation once more. Let's use copy liner once more here, and it will be copied to the third story. So let's quickly add the rest. So I will click to the shear wall, then again to the steel beam here, and also with the bolted gusset plate, we can connect these members here. For the top part, we can add a end plate here. For instance, I will select the end plate connection here. Let's select the column, then pick a point on the top of the column. So as you see, the plate was generated on the top of the circular column. So what I will do, I will get into the macro settings and transform this plate in a circular shape. Okay. So let's continue with the handrail. So we can add handrail also here. So let's select the beam, double right click, and handrail will be generated here. But let's modify this handrail. For instance, I would like to change this end zones actually with a 250 millimeter. Let's apply this change. And let's say that we have rounding at the end and starting of the handrail edge and ending of the handrail edge. So let's apply this also. So as you see, any handrail can be created with this extensive macro settings. So we have recently added a new connection, which is circular base plate. So we can select the section, and the base plate will be automatically generated. With the Control W button on your keyboard, you can determine the correct position of this plate. Of course, you can select anchor button, and you can specify anchors for each hole of this plate. So let's pass to the foundation story, and I will draw stair steps manually in this case. But before this, we need to create points because I would like to use these points as a corner of this plate. So let's click this points. Okay. We can also find the midpoint of these comments with the dividing points comment here. So let's select dividing points. Of course, for example, if you right click and if you select, type in, for example, 3, the software will specify 3 points between those 2 points. Okay. So now I will find the parallel points of these defined points. So let's select the points, parallel points, but first I will right click because I would like to type in 1300 millimeter here. Okay, so let's pick those points. Maybe we can a little bit zoom in here. So one by one, I will offset these points 1300 millimeters away. Okay, the points were generated here. Now I can draw this plate by using these points. Sorry. Maybe I can zoom in a little bit more because it's snapping to the center otherwise. Okay. Now I have created plates. So if you want, you can see this these points because now after this operation, now they are unnecessary. So we can press to the enter button, select points. For example, we have 13 free points here. So I have selected them and we can delete them by delete button on our keyboard. Okay, let's go to the 3D view and we can specify the position with the Ctrl W button on our keyboard. So you can also obtain these shortcuts from our knowledge base. You can check knowledge base for these shortcuts also. So now I would like to move, actually rotate this plate slightly, like 2.5 degree. So in this case, I will use move special command and with the rotate option. Okay. So now I would like to type in 2.5 degree and there won't be any Z offset. So I need to draw a Z direction. So the software will show you the parallel point. Okay. As you see, it's showing the parallel point here. So if we run this, you already saw that it's been slightly rotated. So now I would like to copy this stair step along the column. So what I will do here, I will select copy special and rotate command. But before this, I suggest you to add cut object and also weld object here. So let's do this before we go further. I will select the cut object again, select the plate, then cut object. Okay, as you see with the Alt D button, the cut was applied to the plate. Okay, so the next thing, as you see, we have used this create weld command. So now I would like to show you create fixed weld command. For let's use this. We can select the welded members, the members to be welded, and we can draw the weld, the side of the weld. If you, of course, I can draw all along this part, but I would like to finalize it with the scroll button, pressing scroll button. So let's press our scroll button on our mouse, and the as you see with the purple color, the weld element were defined here. So let's copy this plate for the upper stories. So I will use copy special and rotate command together. So angle can be 17 degree. Z offset, I mean the height of steps will be 180 millimeter, and there will be 15 risers on this spiral stair. So let's run this command. Okay, as you see, it's been generated. So again, I will press to the F4 button, and I will pass to the top view here. You can easily select members from the top view. And what I will do, I will copy this steps to the upper story. So, okay. I can deselect these members also. Okay. So let's copy them. Again, we can use the copy special command, but this time I will use the liner method. So we can add also plate thickness. So I'm gonna type in 3015 millimeters here. Let's copy. Okay, as you see, the stairs were copied and they're already selected. What we can do, we can also copy once more, like this. Of course, we selected anchor by mistake. So what we can do, we can quickly select this and delete here. Again, I will zoom in, select this and delete them. Okay, so let's we also selected the end plates, so we can delete them. So let's create these let's create handrails for this spiral stair. We can use we have some secondary members. As you know, primary members such as columns, beams, trusses must be created in the ProtaStructure environment. But as a secondary member, for example, joists, purlins, girts, stringers can be also generated in the ProtaSteel. So I will select the joist command here and pick a point on the plate. If you press to the enter button, we can define a height along the Z direction. For instance, we can specify 900 millimeter in this case. With the Control W, and Control E button, you can place it properly. And I will double click. We can change the profile for CHS. Of course, you can select any type from here. So I will select the CHS. Okay, let's apply. So let's copy this member to the upper step of the stair. So let's use the copy command. I'm gonna pick a point, reference point from here to the upper step. Okay, I would like to tie also laterally these verticals. So as you see, we can quickly determine the ending points and midpoints on the screen. So what I will do right now, I will match properties of these members with the vertical ones. So we can use match properties command and select the object here. Okay, let's change this orientations again. Maybe it can be okay to the so we need to select a proper position here. To connect these elements, we have a pipe connection macro here, welded pipe connection. It creates cut objects and welds automatically here. So select the member, then the second member, and right click. So cut object and weld will be applied automatically. Again, I'm gonna use copy rotate command along these stairs. So let's select the same settings. Okay, and run. So we have almost completed. Just I will delete the last one. Okay. So also we generate the handrails manually in this sample. Let's show all members here, and in the final part, I will show how we can create truss connection with the IntelliConnect feature. I will select all truss members here, right-click, select the IntelliConnect truss connections option. You can also specify the plate thickness, but I will use default values. Okay, even in seconds, such a complicated connections were generated here. So let's summarize what we have done so far. We have created connections via IntelliConnect feature. We have used handrail macro, stringer holes macro, and floor modelers macro. And also we have seen how we model a spiral stair in the ProtaSteel environment. IntelliConnect automatically assesses joints to your preferences and batch designs connections for you. We have a wide range of simple moment splice and weld connections. It can consider constructability and adjust connections arrangements to suit. Also, it can model additional ancillary steelwork for complete detailing. With the extensive settings of handrail macro, any handrail can be created by clicking on the beam elements. Handrail connection macro can be used to merge this handrail, which are modeled individually. Checkered plate and grating types can be selected as stair step type, and many plate types are available in a large library of the software. Step height is adjustable, and the number of stair step is calculated accordingly. Floor modeler macro has been added to the software recently with handrail and stringer holes. You can create the related floor type for each enclosed beam zone via selecting beams. During the spiral stair connections that we used these macros and commands, these are splice connection, brace connection, creating a connection with concrete members, beam to wall connection, user-defined macro stair steps creation with plate, cut, and welding commands, handrails on each stair step manually. The main advantage of Prota, you can model, analyze, design, detail, and fabricate in a single software. Of course, it's including beam integration with the well-known softwares such as Revit. You can benefit our special pricing, which is 25% discount. It will be available until 28 February. It includes all updates and ongoing professional support. You can also get full e-learning and knowledge hub access. If you want to contact with us, of course, if you're in Asia Pacific territory, please contact from asiasales@protasoftware.com. Except this territory, you can contact with us via globalsales@protasoftware.com. In our website, www.protasoftware.com, you will find the form. So please fill in this form after webinar to get this special prize. If you want to hear more from us, you can follow from our social media accounts. Thank you for your attendance. We would like to see you in the next webinar. Have a nice day. Stay safe. Bye-bye.